All right. So I think we'll get started. It's 12:40. It's my pleasure to introduce Felix Klock. Felix is a staff research engineer at Mozilla. He's worked on compilers and language runtimes in both industry and research since the late 90s. But for the past several years, he's been involved with the Rust project at Mozilla. He is currently a member of the Rust language design team and co-lead of the Rust compiler team. I imagine that many of you listening to this are already familiar with Rust, but let me just briefly say Rust is a very exciting young programming language that aims to bridge the gap between higher level languages, which provide beautiful, safe abstractions, and lower level languages like C and C++, which give you fine-grained control over resource management, but at the expense of safety. And Rust provides both of these things, safety and control, using a very expressive ownership type system. I think it's fair to say that Rust has been wildly successful. Many major software vendors are increasingly investing in Rust. It has been voted the most loved programming language in the Stack Overflow developers poll for 5 years straight. And most importantly, of course, I've been doing research on it, so it's a clear mark of success. So Felix, I'm going to start off with just a question or two from me, just to get things going, and then I'll start asking questions from the Slack. So sort of natural first question is, how did you get involved in Rust?
I got involved with Rust. I guess the simplest way to put it is that I went to grad school with Dave Herman, and he went off and joined Mozilla, and I went off and joined Adobe. And the whole time that I was at Adobe and he was at Mozilla, we each were mutually trying to get the other one to quit their job and join the other one at their corresponding place. And in the end, as it all worked out, Dave was the one who won that battle, essentially. And in the process of him convincing me to join Mozilla, he explained to me about this exciting project called Rust that they were doing in the research group at the time. And that was, I think it's fair to say, like, the thing that just seeing the fact they were working on Rust made me realize, okay, this isn't just a place where I'm going to go and end up having to hack on a JIT compiler for JavaScript, or I was coming with some scars from having done garbage collection research and industrial work for many years, and I was definitely not eager to be back in that morass either. So I was sort of worried about joining Mozilla and ending up working on their GC or their JIT. And as it turned out, I did spend some time working with a JavaScript, working on some JavaScript stuff for them at first. But my real interest when I joined was, I really want to see where Rust goes. And so I managed to sort of join the research group, work half and half with JavaScript stuff, a research effort called Parallel JavaScript at the same time, watching what was going on with Rust, and make my way into that group. And it worked out pretty well, I'd say. At this point, I've been there. Nico Matsakis and I are the two co-leads of the Rust group, and at this point, we're the elder statesman of the group at Mozilla. I think it's safe to say at this point.
And how has your how has your role in the Rust team evolved over time?
Gosh, I mean, it's something where when I first joined, all I was trying to do was, just figure out what was going on with this thing, which at the time, I made this comment earlier about not wanting to be involved with GC stuff, but ironically, one of the first tasks they gave me, Rust originally had a GC as originally envisaged. It had the model as envisaged by Braden Hoare, who was the first sort of developer of Rust, the originator of the whole thing. He was doing it as a side project at Mozilla in his personal time. He envisioned something where there'd be a garbage collected, there you'd have these Erlang style multiple tasks or threads or actors, whatever you want to call them, and each one would have its own independently garbage collected heap. And so when I first joined Rust, that was still part of the linguistic model. And one of my goals when I joined was to try to improve the GC system, because when I joined, the GC system that was there was just a reference counting system. It was just doing reference counting with no cycle collection on each of those local heaps. And the sort of justification for this at the time was, well, it works well enough because each one of these tasks will just sort of run and then eventually die. And when it does, its whole heap will get collected and its destructors run, etc. So originally, my goal was to sort of try to delve into the garbage collection integration problem. And I wrote a number of blog posts on this, which you can find on my blog, where I did some deep dives into that problem and the issues that arise. But in the end, we just eventually evolved into saying, you know what, we don't need this. We don't need this feature. We can get rid of it we can you know, get by with, because our lifetimes in parallel with us working on that or investigating the issues there. At the same time, Nico was improving the lifetime system with Rust and really innovating there in terms of figuring out ways to be very expressive with just borrowed references. And the results of that led to us realizing, oh, like we can just use arena style memory management and get so many of the benefits that we're looking for. We don't need to have a GC heap. Because at some points it was something where we were only supporting it just for bootstrapping the compiler. And once we realized we didn't need that, we said, let's try to get rid of this entirely. So anyway, that's my long story into, like, I sort of was initially tasked with this thing based on my experience in the garbage collection work. But then that turned into just more general compiler maintenance stuff. So yeah, I've been with the team and, you know, helping to sort of, I don't know if guide the language design is the right phrase, because I'm more just sort of in the back watching what's going on as a member of the team, and occasionally, you know, saying something about scheme macros or something. But for the most part, my goal has been largely as a compiler hacker and just trying to keep the project moving forward and stay on top of the bugs that have come up, especially in the more recent years, where as I've taken on a leadership responsibility, a large part of it has been about project management issues and finding ways to resource the tasks at hand.
Right. So the problem that Rust is trying to address is a very old one, and there have been a lot of work in the past in academia and industry on this problem of safe systems programming. Do you have a sense of why Rust has been much more successful than prior approaches? And I mean, certainly when I first heard about Rust, I was skeptical that this problem would be solvable in as successful a way as Rust has been.
That's a really interesting question. I think my personal suspicion is that a reason that Rust has been successful is because while it had as a sort of constraint that it had to integrate with existing systems programs, it had to be able to at least interoperate with C code bases, and, you know, with enough tomfoolery C++ indirectly, but we don't have very good support for direct C++ interoperation, so I can't claim that really. But we get it done. Obviously, it's in Firefox. But the point is, even though it had to have that interoperation, I think the fact that we didn't make a goal being, our goal wasn't, oh, it has to look just like C and C++ or as close as possible, but in fact, we were willing to adopt other linguistic abstractions and make something that was actually palatable to Python and Ruby programmers, meant that the fact we had a language syntax that actually was palatable to that group, and also then started targeting them with our documentation and whatnot, I really think we saw, and still are seeing, a blossoming there, where you saw uptake amongst the Ruby and Python and other language groups, where either they decided, oh, I want to make a plugin or whatever you call it for, you know, some sort of native base piece of code library to link into my Python or Ruby runtime. Once people started realizing I can do that in Rust and demonstrated it on blog posts and wherever else, or Yehuda Katz was a big proponent of this. They were demonstrating like how they had to do something in particular to, you know, just they originally prototyped something in Ruby and it wasn't running fast enough, and it was some sort of instrumentation tool, and they realized, okay, I'm going to have to go to native code for this, and they were scared of doing C. Like their background was something where they knew that was going to be it wasn't their expertise. But once they realized I can do this in Rust, and that led them to actually learn more about Rust and become very involved in the community. I think we've seen that story repeated over and over, where these people from these other languages, they're frankly, you know, just not interested in getting into the C and C++ worlds, and, you know, the amount of technical knowledge they need to have in order to understand what's going on there. And instead, they were able to pick up Rust, get what they needed to get done, plug it in, and go. I think that has been a big part of the success. It's just that we've been able to move into those communities and give those people both a way to either get what they need to get done in terms of they need that native code interface, or if they just are more interested in expanding their own minds and learning about systems programming, how the machine actually works. Again, Rust has provided an excellent path to go from script level programming to systems level programming, where yes, you would learn about types and whatnot, which you could have done via other avenues. But here, it's not just about learning about type systems, it's also about learning about the heap layout and the stack and how those things work at some level. And I think a lot of people have grown a lot from that, and that's led to us making a lot of inroads in those groups, which is, I think, a big reason why you see the most love stat on Stack Overflow.
Right. Okay, great. Let me. Oh, there's some new questions here. So I'm gonna start with a question here, sort of leading in from the previous point. This is a question from Yoshiki Takashima from CMU, and it concerns the use of unsafe code in Rust. So it says, I have a question regarding your opinion on Rust's future direction. The use of unsafe in Rust is widespread and probably necessary. It's also pretty controversial, as seen with the Actix fiasco. Yeah. Given that people flock to Rust for memory safety, what kind of steps are required to assure these users that normal Rust code that internally uses unsafe is actually safe? Recent progress regarding stack borrows seems promising, but it's also a dynamic test. Should we be thinking of adding more static analysis on top of borrow checking? And I guess I would add on to this, just sort of, if you can comment more on the use of unsafe code in Rust, because for me, that's actually a big, that's a very interesting aspect of Rust's approach to safe systems programming that's different from other prior approaches.
Yeah, my own attitude about this is that I think that unsafe, the ability that unsafe code gives you is a part of the story of Rust. There have been some people who push this attitude of, you should eliminate unsafe from code bases, whenever possible. And, while it makes sense to strive for that in some cases, I don't think it's a reasonable thing to just say blindly, oh, unsafe should always be eliminated from everything. There's it's a cost trade-off analysis there. So my attitude is that it's part of the language, of course. It's part of our story about why you can get interoperability with C and C++ and get things going there. In terms of the story then about how to give people confidence about how they're using it, I think, yeah, the main question there is about the work. We have a working group called the Unsafe Code Guidelines Working Group that's working on the specific problem here of actually writing down the rules that you have to follow. And we're talking, and here I'm speaking really solely of the rules you have to follow as a developer, not something that's formally checked yet. So I think that that's an important initiative. And as for the and the other piece of it that's interesting, you bring the stack borrows work. There is dynamic checking that goes on there, but just the fact that that's been implemented, the stack borrows work is implemented in this mirror interpreter Miri, and the fact that that's able to sort of run, and the goal that Ralph Zhang has for it in terms of being able to have something that can run and actually tell you you've had undefined behavior here, and categorize all cases as such, where you'll run as that or not. I think and have that in an interpreter, not in some sort of and with an operational model that sort of makes sense to some. Okay, I shouldn't say that. I shouldn't claim that. It's hard to wrap your mind about some of the rules that Stack Borrows puts in place. I know the other members of the language design team, we have debates internally in terms of like, wait a minute, this rule that we're saying here, that's being proposed here, does this actually like something that makes sense intuitively? Can we actually push this as something that everyone has to follow? But nonetheless, having something that's has some sort of operational characteristics to it, I think is really important. And having something you can run and test out directly and get the signaling thing saying, no, this is going to have undefined behavior in a test that you run. That seems like an important part of the story until until we get much more serious stuff with proof checking and whatnot. I don't see that as being part of the story for Rust in the shorter or medium term, and therefore stuff like what's going on with stack borrows and Miri is a much more interesting avenue to explore, just in terms of giving people an intuition as to what the rules are they have to follow and seeing concrete examples of where it can go wrong.
Great. Okay, a question from Luis Pina from University of Illinois, Chicago. Rust is a great language and actually used by both industry and a growing community of open source users. Given that, I can only wonder how many things you could pick to work on in Rust. How do you pick what's the next thing that you'll work on in the Rust ecosystem? It's a pretty general question.
That is a really well, but it's I wonder if that's addressed at me personally or at the team as a whole.
I think it could be both.
Yeah, it could be both. And arguably, why aren't my own goals the same as the full teams, right?
Yeah.
I think we are struggling with this in some ways. We actually are having some discussions within the compiler team about how to sort of focus our efforts properly. We have meetings. There's 2 meetings every week, or at least slots for meetings every week. And one of the things we're going to be revisiting this Friday in these public meetings that we have is the outcome of a survey we did internally within the compiler developers for the Rust compiler about the problems we face. And the thing that I was just looking at before this thing started was, the main problems that we feel we face as the compiler developers. And so in terms of what things I think that are most important for us to work on, that would give us the most benefits for us personally, as well as for the community at large, the biggest, most obvious one is that compilation times are ridiculously high. Our compiler is just not producing object code fast enough compared to what people expect from other tools. And if we can't get within a closer distance of that, then we're going to see people continuing to say, well, I'm going to keep using C and C++. I'm willing to suffer the fact that these things are unsafe because, you know what, when I give it my .c file or my .cpp file, I get my results back in a reasonable amount of time. And it's got all kinds of tricks it's doing to get that effect. It's got they've got their precompiled headers and whatever else they're doing in order to work with that language. But we've got to do similar kind of magic on our end. So that's the biggest one that I think we need to attack. And we've talked a lot about this internally in terms of how we can fix that problem of compilation times. And the most obvious answers before us are, well, we have an incremental mode for the compiler, but we are certain it's not working well enough as it should. There's avenues to explore there in terms of making the incremental mode better, in terms of just making the compile edit compile debug cycle faster. And the other avenue to explore is parallel compilation, improving the parallelism within the compiler. And that is something that unfortunately we just don't have the resources to continue investing. It's the obvious thing to invest in terms of the long term, like both in terms of process architectures and the future of everything. Just looking at the various kinds of 64 core processors out there, all this kind of stuff. It seems like, okay, you need to leverage that if you want to have something fast in the future. But at the same time, parallel compilation is not going to reap those benefits to our average developer compared to incremental compilation in the short term. It's going to be very expensive to implement, I think, and it's going to be hard to see the benefits of it until you see those massively parallel architectures much more mainstream, I think. So in terms of things that I would work on, I personally want to focus on compilation times and particular incremental compilation. That's one of my main focuses personally, and I think for the team as well, as something we're going to be attacking. There is also the possibility of attacking the problem by saying, well, we are laden with technical debt, for example, from using LLVM as a backend, which is easily taking up half the compilation time, and depending on your point of view. And so there is also the option of trying to sidestep that by using a different backend, which we are exploring. But I think it's fair to say it's not going to reap. I don't think we're going to see anything there in the immediate future, at least. It'd be great if we did. It'd be great. There's talk of like using the CraneLift backend, or even I've considered like, could we just have output mirror and use a mirror interpreter as our backend for development work? But it's not going to happen anytime soon.
All right. I guess a somewhat related question, at least to what you were just talking about in terms of compilation, from Emmanuel Lima, University of Sao Paulo, who writes, what do you think are the biggest opportunities of improvement on the optimization phases of the Rust compiler? And do you have any advice to someone who wants to contribute both to Rust C or do research on Rust C optimization?
Okay, so there's a lot of work going. So your options here, that's interesting. There's a couple different avenues to take. One is to say, well, we are relying on LLVM to do all of our optimizations. So you could invest your time in trying to make existing LLVM optimizations better, either by making them run faster or add more LLVM optimizations. And the interesting detail there is that the LLVM optimizations tend to be tailored to Clang produced LLVM IR, or perhaps Swift produced stuff. I'm not, sure exactly where the boundaries lie there in terms of what Apple does and where they focus their efforts. But the point is that it certainly isn't optimized for what Rust produces unless we ask them to, or unless we come up with an example and say, hey, this particular bit of IR is not handled well at all by LLVM. So that's one way to go. Obviously, it's not the way I want to encourage people. Sorry, it's not obvious at all. In terms of what I want to encourage people to do, I think that jumping into developing for LLVM might not be the best thing for our project, because in the end, what we'd prefer to see is people working on, I think, some of the mirror optimization work. So we're doing some work on actually optimizing the mid-level intermediate representation that Rust uses internally. And by applying optimizations there, it means that you can do a little bit of work up front and end up then sidestepping LLVM having to do the same work when it runs. So you end up having a faster compile time by feeding less code. For example, if you can get some code reduction in the mirror phase, then that means you're feeding less code to LLVM, which means that you both save on compilation time, and you're probably not going to get better optimized code out of it. Hypothetically, you might say, oh, you have more knowledge at the mirror level, but for the most part, my knowledge of what the people doing in the mirror optimization group, for the most part, it's more about compilation time itself. It's not about having a better optimized compiled artifact, because it's pretty hard to compete with LLVM on that front for the most part right now. And the last step of this is maybe, looking at the interface between the two, figuring out some way to make what the Rust compiler produces more palatable to LLVM. So those are the three high-level areas I could tell someone to look at. And honestly, I think the most excitement is happening in the second one I said, the mirror optimization area. There's a working group. I mentioned before, there's a working group for the unsafe code guidelines. There's likewise a working group for the mirror optimizations. They have a dedicated chat room and active work they're doing. And I think there's a lot of interesting stuff that's been coming out of that. So someone who wants to get involved, I think you definitely reach out to people there. And the last thing I'll note is that one thing that we have noticed and discussed recently in terms of optimization work is code gen units are the way that you partition up your code and then feed it to LLVM for parallel processing. And I think that there's general agreement amongst the team that our partitioning system is not ideal. And so there's some interesting work that we're going to hopefully attack there to try to figure out how to improve our partitioning scheme in various ways. But it's not clear to me, how soon we'll see results there, but that's another avenue of something to explore.
Okay. A follow-up question from the same person. Do you think it's feasible to apply machine learning techniques to Rust C optimization passes?
I don't know. I would love to give like a sort of pat, like, oh, sure, of course it would be, but it depends on what you'd have to have something that I've seen, like, sort of exhaustive search done in other contexts of, trying to find idealized code generation patterns. And, so when I hear machine learning being applied to this kind of problem, that's the sort of thing I envisage. So I guess it's possible, but I think my main concern there would be whatever product you get from the machine learning, is it going to be something that's actually maintainable by the Rust compiler team itself? Is this something, where you're talking about it just, spits out these you have something that with some parameters and use machine learning to figure out what the ideal values of those parameters are, and then everyone sort of says, well, and then with the caveat that any value for the parameters is correct, it's just a matter of which one produces the most optimized output. Even with a system like that, where you'd say, okay, this sounds pretty safe in terms of different values of the parameters shouldn't make the code incorrect. Even there, you might see people saying these are just magic numbers. How do I understand changes to this thing? Same time though, you see people putting magic numbers in the code anyway, and just saying, well, it looked good, it worked out well in my own workstation. So that's no different from applying machine learning to a case like that. I'm feeling a pretty waffly answer here, but I feel like it's because
yeah, I think yeah.
I think that there's certainly potential, and it could be that I'm misunderstanding what the question might be thinking of, because you could be talking about super optimization, where you sort of explore all possible code patterns and then work to prove that the one you generate is actually equivalent to what you started with. I don't know what the sort of thought about what kind of machine learning to apply here, but think that anything's possible, but it might be you definitely want to talk to the compiler team first before exploring it if you actually want to land the code base,
Right.
to make sure everyone sort of can stomach it or understands what is being suggested. Having said that,
All right.
for research work, go ahead, go publish paper. It's fine. We'll happy look at the paper.
Right. I should add, it's actually for people who are watching, it's 1:05 in the morning where I am. So that means the next PLDI research paper session started 5 minutes ago. So if you're interested in going to the security session, then please do so. But we're going to keep going here for a while. So next question, John Wickerson. So changing tack a bit here. John is from Imperial College London, in case you didn't know. He says, Mozilla is quite a distinctive entity in Silicon Valley for its focus on free and open source software. Are these values important to you personally as a Mozilla employee, or are you only interested in the technical aspects of language implementation?
I think I am very interested in free and open source software personally. My job before this was at Adobe, where I was working on Flash, and that certainly is a closed source system. However, at the time when I worked there, the part that I worked on was the ActionScript virtual machine, which was open source and actually was being co-developed with Mozilla. They actually had it hosted on a Mercurial repository on Mozilla servers. So I would say that I've known some people in my life who absolutely refuse to do any work that wasn't open source. I am not that level of zealotry when it comes to this sort of thing. But certainly when given the option of, two otherwise equal, kind of jobs, or even, I would say, I would take, pay cut to work on open source stuff. So not even otherwise equal. The point is, when given the two options, I definitely weigh heavily the idea of open source development as part of it, because I frankly love the idea of being able to put these things out there, get feedback from the community at large. Rust is an amazing instance of this, where we have so much of the development is coming from the outside community. And then after the fact, being able to point at it. I had work I did 10, 15 years ago that I can still point to from my, either my graduate work or from work at Adobe, whatever, and I can still find the bug reports. I can still point to them. And I think there's a beauty in that doesn't happen for the work that I did, under when I was working commercial vendors, and I don't have access to the source code or the bug reports for that kind of work. So yeah, I think there is a beauty to doing open source as an individual developer, and I think it's a great thing for the world overall. And the main problem with it is that there is an issue of sort of this expectation of unpaid labor to some extent amongst open source projects. And sort of, expectation that there's some social issues to work out, I guess is what I'm trying to say. And there's been some communities that are rather toxic. And we were lucky. I think the Rust community is lucky in that it was initiated by someone who was very aware of toxicity issues and instituted a code of conduct from the outset, which was at the time, I don't think it wasn't standard at that time to have a code of conduct in the communities, but since then it has become standard in a lot of communities to have a code of conduct. So anyway, yeah, I think that it's important to me. It's important to Mozilla. It's important to Rust, and yeah.
Yes. So actually, your answer reminds me of another question, which is you mentioned Rust has really benefited hugely from this huge community of contributors outside of Mozilla. How, aside from or in addition to the code of conduct, how do you manage that?
Huh.
This seems challenging.
Yeah,
maybe that's too big a question to answer.
No, well, I mean, we manage it. It's interesting. It's not all unpaid labor. We have some people that are literally, some of my work is spent in project management type stuff, and we have paid other people to do project management type stuff solely about just sort of organizing the issues that are facing us and charting out where we're going to go in the future. I think that, to be honest, we've been organizing it as an open system since the beginning, effectively. And it's only this year that we've made an explicit goal of realizing that our processes are not ideal. In particular, we have an open RFC process that we use for allowing anyone to suggest language changes. And as part of the roadmap, the Rust, there's a blog with Rust stuff, and the part of the 2020 roadmap for Rust is that a recognition that our governance system has to change because our community has grown so large that the systems that we have in place, we knew that they weren't ideal and they don't scale. And it's become to a point where we have to do something different, because just getting through the conversations and resolving conflicts is so exhausting and draining to everyone involved that it causes real emotional damage. There have been a number of people who have left the project, talented workers who just said, you know what, like, this is too much. I can't deal with the kinds of feedback that are given here, or just working with certain individuals, whatever it is. It's something where it just happens that way. Some people go. And so I think we've realized that it's a risk that we've had as a project for a while, and we had let it go unaddressed for too long. So we are working to sort of come up with more streamlined processes. Well, I don't know if streamline is the right word. We're adding, in some ways, some more bureaucracy in certain stages, but still trying to keep them lightweight. It's sort of like we had like a one-size-fits-all system before. It's the RFC process, for example. And what you effectively had was trying to use a GitHub issue comment thread as a basis for discussion, which is bonkers. Like, it just isn't what it's designed for. I mean, you might think a comment thread is a basic. It sounds like it's going to be a basis for discussion, but it just doesn't. It doesn't make sense. It doesn't scale, especially with the number of comments and the length of the threads that we were seeing. So, yeah, I guess my answer is we haven't managed it perfectly. We're exploring other ways to manage it better and to try to keep ourselves focused. And the most successful thing that I can say, I think, is that when we managed to sort of identify a problem and identify a relatively small team of people to focus on it and attack it. And that's where we've seen, for example, the non-literal lifetimes work was an example of something where we built up a small group of dedicated volunteers and pushed that through in time for the 2018 edition. So that was a very successful, effort. And likewise, I mentioned before the mirror optimizations working group. That's another example of something where you just got a small group of people dedicated and pushing through with their own isolated sort of chat area and way of tracking issues and whatever else. And then they occasionally bubble up to the rest of the compiler team saying, hey, look, this thing we made. It's really great. I think that's the kind of model that we'll be seeing more and more with our organization, just because it seems like it's been successful more often than some other models we've attempted.
Okay. Question from Sabri Blackman from Transparent Systems CU Boulder. One of the questions I often get about Rust is it functional? The ambiguity of that question notwithstanding, how do you come to terms with Rust's seemingly contradictory language paradigms? Monads, but not really. Feels OOP, but closer to type classes, etc.
Yeah, I guess so. I think it's sort of, hey, I'm a schemer at heart, and so to me, like, people will say, oh, it's the same situation there, where it provides a lot of the basic operations and functions are based on applicative programming and essentially functional programming, but at the same time, it offers you all the imperative goodness that you could want. And I sort of see Rust in a similar light. It's something where if you want to program functionally, we have worked hard to provide you with a standard library that encourages functional programming. And we've worked hard to provide the compiler, to give the model the compiler uses, something where you end up with efficient code even after programming functionally with closure, higher order functions and whatnot. So yeah, I guess that's my attitude, is that sort of like you get to use what you want, and hopefully you don't get burned by it in terms of you don't end up with object code that's more inefficient than you had realized it might be. And I don't think it's too incoherent. I don't know. It's a funny question, because there's some places where I really thought that there was things of beauty when I first was looking at Rust, in terms of, for example, how the trait system is melded with the object system, where it's just something where you have this essentially a type class type system, but then as soon as you add a level of indirection behind a pointer, it suddenly becomes a V table. And I don't know, I like that. I guess you could argue a dictionary dispatch system is similar anyway, so it's not that different from what you see in various implementations of languages with that kind of system. But to me, there was a beauty there. And is it object-oriented? Not exactly, not the same way that Java or C# is, but it's the kind of object orientation that I like. So yeah.
So perhaps an even more provocative follow-up question would be: are there specific features, or of functional or object-oriented or whatever paradigms that you or the other Rust developers specifically have avoided, and why?
Oh, avoided. I mean, there's
or that you have adopted in a much more limited way than they are in
well, the big one I can think of actually is the big one that we don't have that we may need to end up having at some point in some fashion is so the way that we handle vtables and objects is that if the vtables are attached to the references, you have the pointer to the actual data, the structure you have, and then the methods attached for it are part of the pointer. It's a fat pointer with the methods there. And so you end up with something where this differs from Java or C++ or C#, where there the vtables, you have a single word pointer to the object, and the vtable for the object is there's a pointer to the vtable from the object itself. And so the reason why I bring this up is because, one, it means that Rust doesn't have the same kind of inheritance system that other languages have. Those other languages, that one vtable encodes information about the whole hierarchy, but this thing with the fat pointers, you don't necessarily know that the structure you point to implements these other interfaces. All you know is the interface that you have the vtable for right there. And you might know about, you know about the super interfaces it has, but the whole interface graph as a whole is not part of the story that you get there. And that means that this can be annoying for some people to program with in some situations. And it also is an interoperability hazard, I think. And that's a reason, I think, why we don't see C++ interop right now, because we don't have a way of expressing directly the object layout that you have in C++. So that's something we've avoided having. We've avoided having that style of inheritance for various reasons. And the question is, can we continue on this way if we want to eventually have good C++ interoperability? And I don't know what the answer is there. Right now, our focus right now is actually on just achieving C interoperability in terms of having, but not interoperability, sorry, feature parity. Just being able to, we want to get to the point in the short term or medium term of saying, look, anything you want to do in C, you can do it in Rust too, and with roughly equivalent amount of headache, depending on how you look at it. So for example, our inline assembly support is currently something that's not stabilized. And we've left it unstable because it was tightly tied to LLVM. And so we've been working on trying to revise that into something that isn't so tightly tied to LLVM's particular assembly syntax or assembly system. And there's other examples of things like that, where basically we have a list of things where to achieve parity with C, we need X, Y, and Z, and we want to get those taken care of first. So yeah, that's my way of saying that we aren't going to get to the C++ parity or interop story anytime soon, but it's been something that's been talked about for a long, long time, since before, since I've been on the project, it's been an issue because of the Firefox developers, obviously, needing something that works with C++, and the kind of headaches they had to go through to deal with the fact that we don't have, the most seamless C++ interop story ever.
Okay. Question from Julia Beliakova from Northeastern. Rust seems to have a pretty rough learning curve. Do you think there are any specific preconceptions coming from experience with other languages that make Rust hard to learn?
Maybe. I don't know. This is a tough one. We've been struggling with this because we do a survey of we try to do a survey that includes both Rust users and non-Rust users and get feedback from it. And you're right about the learning curve. One of the most striking things that we saw in our most recent survey is that there are people who, according to the survey results, said they have been programming with Rust 4 years as their main job, and they do not feel productive in it. And that, to us, is very scary. Now, the phrasing is important. They don't feel productive in it. We don't know if they actually are unproductive or not. but they don't feel productive. And so I think personally that it could be an issue where, you know, the mismatch between other languages and Rust itself is a problem. But I suspect the biggest issue actually might be that our IDE support has been lacking, and that's going to be a focus. I think one of the main big focus for us is in the 2020 roadmap is to try to get the IDE support to be something where it's on par with what you get with visual code and other languages. You know, we really want it to be something where, and for the most part, it's actually pretty good. There's this project called Rust Analyzer. I'm going to try to compress this as much as possible. We delivered something called the Rust Language Server, RLS. It was developed by people within Mozilla, you know, to just get IDE support out there. And that was what we deployed as the official IDE support for Rust. And this other project, Rust Analyzer, came up and basically said, well, the way that you're doing with RLS is terrible. And it doesn't match what you need for an actual good IDE experience in terms of being able to, like, you know, have immediate feedback after a few keystrokes. And so they developed this other thing called Rust Analyzer, and it really is pretty marvelous to work with. So one of our goals is to actually make Rust Analyzer be the basis for RLS 2.0, to be the thing that we deliver as the official IDE experience with our tools. And I hope that just improving that could help a lot with the learning curve. I could be wrong. It could be something where there's just fundamental linguistic things that are going to be a barrier. But I personally hope that a better experience traversing the source code that you're working in will help people work with the language, and having things like tooltips and whatnot, especially if you can get better feedback about the most important thing, other than, you know, just general support for a better IDE experience, having support in the IDE for giving feedback about what lifetimes are and what they mean, like, you know, giving better diagnostics, leveraging the GUI interface of the IDE would be pretty cool. If we could, you know, figure out a good way to visualize the life, you know, if you like hovered over a reference something of some certain reference type, and you've got like a highlight of what its lifetime is, syntactically would be, as an example, of something that would be kind of cool to think about. So I don't know if that's the answer, but it's what I'm pinning all my hopes on right now.
Right. Wen Wang from University of Georgia is asking about WebAssembly. What's going on with Rust and WebAssembly?
So I think I'm not an expert in WebAssembly, but I think there's this thing called the Bytecode Alliance that is they got a bunch of different industrial partners jumping in, and it's basically, you know, pushing WebAssembly as the promised, you know, delivery of your application in a sandbox that's actually efficient, and you know, something that's been talked about since Java was, you know, being pushed by Sun in many ways. It's something where that it's not an area that I'm an expert in, to be totally honest with you, in terms of like what the motivations are. But I can tell you that, as I understand it, WebAssembly itself is being pushed as, you know, this amazing thing for not just in the browser, but for just standalone applications. It's a great target for development, and Rust has great support for it out of the box right now. And so in terms of what the story there is, I think that is the story, that like we've got really good support for it, and it's a very exciting target. Beyond that, honestly, I don't know what else to say, because I'm not well versed enough in the other source languages that target WebAssembly. I mean, as far as I know, you can, you know, compile C to it, but I don't know what the experience is like when you do that.
Yeah. Joseph Cutler from Wesleyan asks, Rust has created lots of excitement around safe systems programming among practitioners. Do you expect or hope that this excitement will lead to more safety features in the style of Rust being adopted in other systems languages, or will Rust remain in a unique position in this space?
Huh. That's a very interesting question. Like, it's because one of the sort of hypotheses that I've seen pushed by some of my colleagues at Mozilla is that you can't get away from things like the lifetime system. Like this, there's been some people who said, oh, we'll make a version of Rust, but we'll get rid of the complication that the explicit lifetimes present. And the claim that I've seen made is sort of, you can't get this, you can't get the final result that we're looking for of having, for example, independent compilation of the individual functions and not paying for global analyses without having that explicit statement of your interface requirements via the lifetimes of your references and the constraints between them. We get a lot out of inference in a lot of cases and various kinds of elision tricks, but it's just going to be part of the interface. And the reason why I bring this up then is to say, well, that's the most obvious thing that like is the innovation that Rust provides. So much of what Rust has is just old things that were put together in interesting ways. The lifetime system, in terms of, is something novel with respect to what has been deployed successfully in industry. I think that's you can make arguments that it looks a lot like some other things from research, but it's in terms of being successfully deployed, it's I think the main player there. And so in terms of what then gets adopted by other languages, it's really interesting about whether other languages could stomach adopting lifetimes. It seems like a hard sell to me, but maybe it'll be inevitable. Maybe it's something where just for interoperate, if Rust were to become successful enough, then at some point you could argue, well, interoperation with Rust will require some way of specifying lifetime constraints, but we're not there yet. We're not playing at that level. We're still trying to, have a seat at the table, not be dictating things to other people.
Right. Ben Carroll asks, so this is a very different question. It's not really related to Rust specifically, but what's the backstory behind your dissertation? How did you choose the topic, and what was the research journey like for you?
Oh gosh. Okay. So I guess the easy way to tell this story is I went back. I worked for an industrial compiler company, Green Hill Software, back in Santa Barbara for a couple of years. And then I decided I wanted to go back to grad school because I felt like I wanted to, I don't know, benefit the world or something. I felt like, I'd be better off in research. And so I went to Northeastern to do my graduate studies. Largely, the two big reasons were they had such a strong group of programming language professors in the programming language research team there. At the time was Mitch Wand, Will Klinger, and Matthias Fleisen, and since then they've grown the faculty even more because they got Olin Shivers and a bunch of other people who have joined on since I was there. But the point is that I sort of had this choice between these three professors to work with, and I ended up working with Will Klinger, who is his baby, or rather his former grad student Lars Hansen, and Will had made this scheme runtime and effectively JIT compiler, one of the scheme systems where every expression you type in would get JIT compiled to native code. At the time, it was Spark native code. One of the things that I worked on while I was there was getting it to actually be able to JIT compile to something other than Spark, which is because at the time we're talking in the 2000s here. Like, you really don't want your main machine code backend to be Spark RISC. So anyway, the point is, I was working for Will, and it was a matter of just saying, well, this thing is meant to be a compiler and garbage collection research platform. In fact, largely a garbage collection research platform. So because that was the main thing that Will had in front of him, and I decided to work for Will, that's how I ended up working on GC research. It's one of those choices where you look back on life and you wonder, how did I end up there? And that's the simplest way to put it. I want to be clear here, I guess, because I remember at the time, debating with Will about garbage collection, and it's a debate I suppose it would be good to have again now that I've been working on Rust for so long. At the time, Will pushed the idea that garbage collection is crucial for modularity, that it's a key component in modular software development, just because you need to be able to link these components together without concern for memory management issues. And I think it's obvious that Rust is trying to push another view here, that's saying you can have modularity, it's just you have to specify the ownership things within the interface and the lifetime relationships as part of your interface. And so the interesting researchy question that's arising here from the community at large, you see bubbling up from the developers is, well, is this tenable? Are the interfaces that Rust developers are making, are they actually reasonable for people to work with? Or in the end, is it something where it's too much overhead in one's mind mentally to try to work with, and you're just better off saying, no, let's use a garbage special language and not have to specify this stuff as part of our interfaces all over the place. I think it's still I think that's a very interesting sort of programming language design question that we don't have the ability to answer it yet because the language hasn't been around long enough to really properly answer it. But I wouldn't be surprised if in, 5 or 10 years, you start seeing researchers trying to do deep dives into questions like that in terms of evaluating whether it's even reasonable to be programming in Rust at all compared to a GC language. So yeah, that's how I got into GC stuff, is because I believed that there was no other option. And then I found Rust and I was like, okay, there's another option for doing this kind of coding and not having to use unsafe abstractions.
Right. So I think that's basically it for the Slack questions. I have one final question, just to bring things back to one of the earlier questions about unsafe code. So to me, I found that Rust is one of the things that's most exciting about it is that it's really very different from, although it inherits a lot of features from functional languages and object-oriented languages and academic languages and so forth, it really has this, puts forth this new point in the design space of a kind of extensible type system, right? So there's this idea that the types have, of course, they have the sort of the standard meaning in terms of what shared references mean and mutable references mean and the properties you associate with those. But those can actually be extended. You can, for example, define libraries with interior mutability where you can suddenly mutate through shared references, and that's actually okay. And that can be used to express, a really wide range of different APIs, and people keep coming up with more and more interesting APIs that sort of push the boundaries. This is not something I've seen. Of course, other language, and I should say this is, of course, enabled by sort of embracing to some extent unsafe code that's been encapsulated in these APIs. And that's not something, although other languages do have unsafe features, that I haven't seen it used in such a sort of to such an extreme to embrace extensibility of the language. And I'm wondering, is that like how did that come to be? Because that's something that, to me, Rust is really going well beyond what people have done in academic research on these kind of languages, and so I find that very impressive.
Yeah, that's an interesting thing. So I guess you're pointing out the fact that type system itself is extensible, or at least people are finding new ways to express interesting things within the substructural type system that we offer.
Yes.
And that it melds well with them then implementing the corresponding thing they're trying to express in unsafe code and whatnot. That's true. I think that I'd be careful, because I think there's been instances where people have come up with abstractions and implemented them and then come to realize, oh wait, like I didn't realize that I needed a phantom data here or something, and like this other has this consequence I didn't expect. We don't have a good story about sort of globally proving that what you've done makes any sense at all. I think in terms of, because we don't have, like I said before, the unsafe code guidelines haven't been formally written, and I'm just thinking offhand, off the top of my head, about cases where people have made changes to certain abstractions or certain core library types, and thinking, for example, what's a good example of this? The case I'm thinking of is something where somebody made a change to something and said, oh, there's this phantom data here. The phantom data is this abstraction that just basically means you can say phantom data of some type T, and it means act like there's this type T here, but there's not actually a type T there. It's not, there's no space allocated for it or anything like that. It's just meant to be there for the type system. And somebody got rid of it. I can't remember why they did it, but then I looked at it later and saw what they did and said, no, you need to have that there because it's going to actually force the drop check system to force that this thing outlives other things that have references to it. And that's the kind of example where somebody didn't realize about that problem coming up. And so I think we've seen and then the other sort of case of this is that there's been this pin type that was introduced as part of async await support. And there's been a whole slew of interesting questions that have arisen of new things that have problems that have cropped up with the introduction of this type. And it's something where, again, people didn't anticipate all the ramifications of the abstraction they added in. So this doesn't answer your question, because your question was like, how do we get this thing? And as far as I know, it's entirely accidental. I don't think that
that's very impressive to me.
And maybe that's wrong. I mean, maybe there's something where if you ask Nico the same question, he would say, "Oh no, of course we always intended to have this level of ability to plug in these new things." But I don't think so. I think a lot of us have been really surprised and impressed by the expressiveness of what people have come up with in various ways with the tools that they've been given. And yeah, I think some of it you can claim, oh, well, this was a natural occurrence of the kind of philosophy of having small pieces that you plug together, again, a very schemely kind of mantra there. But no, I can't claim that this was something that was deliberately anticipated, that kind of outcome was anticipated. I don't think so. I'm going to go with accident for now. And an accident that leads to accidents, as I was trying to, that was the point I was trying to make, is that, sometimes people think they have something that makes sense and it doesn't.
Sure. Of course.
Yeah.
Well, I would say it was a happy accident.
Oh, there we go.
So thank you very much, Felix. And this was a pleasure. And that will conclude